Hi everybody, let's do IXL 7th grade AA7. Go to Learning, make sure you're on Math, go down to 7th grade, and then click on AA7, which is Volumes of Cubes and Prisms. Okay, before we do this, let's head over to frydmanmath.weebly.com. And you can see that volume is on page 12 of the reference pages. So let's go down to page 12. Here it is, page 12. Volume is over here on the left side. So let's read a little bit about what volume is. Volume is the number of cubic units, and cubic units are cubes which are 1 unit long on each edge, that can fit inside an object. So here's an example. The rectangular prism above contains, well, you can see that the length is 5, so it's 5 units from the left to the right. It's 2 units from the front to the back, so we can say that the width is 2 units, and it is 3 units from the bottom to the top. So we can say that the height is 3 units. Now, how many little cubes, which is sort of like a square but three-dimensional? It's the three-dimensional analog to a square. So how many of these unit cubes, which is a cube where each edge is just 1 unit long, can fit inside of this prism? Well, to answer that, we would just multiply all of the edge lengths together. So we could just do 5 times 2 times 3, and that would give us 30. Now that is for a rectangular prism. In general, when you are finding the area of a prism, you don't simply multiply all of the numbers that you see together. In general, what you would do, and let me get my marker over here. So generally speaking, you would find the area of the base. So imagine that you have X-ray vision and you're just looking at the base of this prism, which happens to be a rectangle. I know that looks like a parallelogram, but that's just because I'm trying to draw something two-dimensional in three-dimensional space. So basically, the idea to find the volume of a prism is to find the area of the two-dimensional base. So over here, this would be a rectangle. And to find the area of the rectangle, it would be 5 times 2, right? And that would give me 10. And then multiply that by the height. So 10 times 3 would be 30. So it turns out that for a rectangular prism, you are just, in the end, multiplying all of the numbers together. But you're not going to do that when it is a triangular prism or a cylinder. Okay, for a triangular prism, you would have to find the area of the triangular base and then multiply that by the height. For a cylinder, you would have to find the area of the base, which is a circle, so you would use pi r squared, and then multiply that by the height. Okay, so for a rectangular prism, you find the area of the base, which is a rectangle, and multiply that by the height, and that turns out to be the easiest one. Okay, but in general, it's to find the volume of a prism, you're going to find the area of the base and then multiply by the height. Okay, so it's going to be pretty simple. Let's go ahead and do some IXL problems. So what is the volume here? You know what? You could just do 8 times 8 times 8, but I don't want you to get in the habit of just multiplying the numbers every time you see a volume problem, because you're going to get confused when you move on to cylinders and triangular prisms and anything else. So I'm going to do this the long way. I'm going to write out that the volume is equal to the area of the base. This is what I'm going to use to represent the area of the base times the height. So on the next line, we have the volume is equal to the area of the base. This is the base over here, which is a square, and the square is 8 by 8. So for the area of the base, it's going to be 8 times 8. And for the height, we have another 8. So we have another 8 for the height. So yeah, in the end, we end up just multiplying all the numbers together. So we have 8 times 8 is 64. And then 64 times another 8 is 512. So that's going to be 512 cubic centimeters. Right? And I'll just oops, not 2, 3. So remember, this was, even though I didn't write it, this was centimeters, this was centimeters, and this was centimeters. So if we do centimeters times centimeters times centimeters, then we get centimeters to the third power, or centimeters cubed, which is why IXL is writing cubic centimeters over here. Okay, so let's move on now. What is the volume? So again, volume is equal to the area of the base times the height. So again here, the area of the base, well, the base itself is another square, and that is 7 by 7. So to find the area of a square or a rectangle, it's just the length times the width, which is 7, in this case 7 times 7. So for the area of the base, we'll write 7 times 7. And for the height is also 7 inches. Well, okay, the color doesn't really matter. I forgot to change colors there. But that's okay, it doesn't matter. So the volume is 7 times 7 times 7, which is going to be what? 100, yeah. So 49 times, so 7 times 7 is 49, times another 7, we will get 343. 43, okay. All right. Volume of the volume of any prism is equal to the area of the base times the height. So the base here is a rectangle. That rectangle is 8 by 9. So for the area of the base, we will write 8 times 9. And for the height, we have 7. So it's just going to be 8 times 9 times 7. $504. And again, that is cubic centimeters, because we're measuring units of centimeters 3 times. So this was centimeters, this was centimeters, and this was centimeters. And if we do centimeters times centimeters times centimeters, then we get cubic centimeters. So that's why we have that exponent of 3 there. Okay, I'm going to jump ahead to the next level. Well, let me take a look at the next problem and see if it's different. No, so this one's the same. So I'm going to jump ahead to the next level. What is the volume? This one also looks to be the same. So I'm going to jump ahead again. This skill is not particularly difficult. Going to jump ahead to the next level. Okay, so this one is different. This one says that the volume is 1,000 cubic meters. So this time we do not know what the side lengths are. We do not know what this is, or this, or this. Although we do know that they're all the same. This is C, this is also C, and this is also C. So we do at least know that this is a cube, so all edges are the same length, but we don't know what that length is. We do know, however, that the volume, I'll underline it again, the volume is 1,000 cubic meters. So what is the value of C? So let's go ahead and write our volume formula for a prism. We have that the volume is equal to the area of the base times the height. Okay, now in this case, we are told that the volume is 1,000 cubic meters. If I wanted to write the units in, I could put an m here with an exponent of 3, but this is all going to get very cluttered if I write all of the units, so I'm just going to leave that out and just write 1,000 here. So this is equal to the area of the base. Well, if I knew what C was, if I knew what all of these C's were, then how would I calculate the area of the base? Well, we would do, since the base here is a square, we would simply do C times C. And we can write that straight into the equation. So far we have 1,000 is equal to C times C. But now we have times the height. Well, the height is also C. So we can plug that in as well for the height. So we have another C there, right? That's the height. Okay, so what we have here is 1,000 is equal to C times C times C. So now we have to think to ourselves, what number, if we multiply it with itself 3 times, gives us 1,000? Is it, I don't know, maybe is it 22? Let's try. 22 times 22 times 22 is not equal to 1,000. No, so that's no good. Let's try 21. 21 times 21 times 21. No. Also no good. Maybe 20 would work. Let's try that one. 20 times 20 times 20. Is that equal to 1,000? No. What about 10? Let's try that. 10 times 10 times 10 equals, oh, that is equal to 1,000. So if all of these over here are equal to 10, then we would end up getting that 10 times 10 times 10 is 1,000, right? So we would get 1,000 on this side, and we already have 1,000 on this side. So that works. So each of these side lengths, which were labeled C over here, must be equal to 10. So this was 10 over here. The height was 10, the width was 10, and the length was also 10. Okay. Okay. Again, we have a problem where we know the volume, but in this case, we're trying to find the width. So the volume of the rectangular prism is 24 cubic yards. We want to know what the value of m is. So we want to know what this is over here. Let's write our formula. Volume is equal to the area of the base times the height. So 24 cubic yards is equal to find the area of the base here is a rectangle. All of the bases have been rectangles in this exercise. Remember, a square is also a kind of rectangle. So how would we go about finding the area of the base if we knew what m was? Well, we would do m times 3, or if you like, 3 times m. So I'm going to write 3m over here times the height, which was 8 yards. So we can write 8 over here. So now we have 24 equals, and you know what we could do here? There are a couple of different ways that we could solve this. We could divide both sides by 8 and then divide both sides by 3. Or we can, all of this is getting multiplied out, right? So the order of multiplication does not matter. That's the commutative property. So instead of doing 3 times m, we could do 3 times 8, sort of jump over the m. And we could say that that is equal to 24, but the m is still there. So we'll write 24m. And now we only have one number to get rid of. So this 24m really means 24 times m. So in order to get rid of the 24, we have to do the inverse of multiplication, and we have to divide both sides by 24. So these cancel, and we have m on this side is equal to 24 divided by 24, which is 1 on this side. So that means that the length of this side is equal to 1 yard. There we go. Okay, this problem is exactly the same as the last one. So I'm going to go ahead and jump to the next level. This one is actually easy enough to do in your head, really, because if you see that the volume is 4, so then you can ask yourself, 2 times 1 times what equals 4? And that would be 2. 2 times 1 times 2 equals 4. Again, this is another problem where we know what the volume is, and we have to find the length of the base. Okay? All right, what is the volume? So this problem is not like the last ones, the last few problems that we did. This problem is like the first few problems that we did. Here we would just have to multiply all of the edge lengths together to get the volume of this cube. So I'm going to go ahead and jump to the next level. Okay, so it's a word problem. The same idea as what we've done before. Maybe just sketch it out, and that might help. So each side of a cube is 2 meters long. So you can draw a little cube, and it says each side is 2 meters long. So this is 2 meters, this is 2 meters, and this is 2 meters. What is the volume? Again, volume is equal to the area of the base times the height. So the base here is a square. To find the area of the base, we would just do 2 times 2. So now our formula is volume is equal to 2 times 2, which was the area of the base, times the height, which was also 2. So 2 times 2 times 2 is 8. And remember, this was actually 2 meters, 2 meters, 2 meters. So when we do meters times meters times meters, we would get meters cubed, or cubic meters. Right? So let's put that in. Oh, Okay, so we got our first triangular prism. That's interesting. I actually thought this exercise was all rectangular prisms. Which is, so I'm glad that I showed you the formula, area of the base times the height, instead of telling you to just multiply all the numbers, because now you're going to see that would have been confusing if I had told you to just multiply all the numbers, because that's not what you're going to do in this problem. Well, although this problem is actually not that different from a couple of the problems that we've done. So let's just read through it. A triangular prism is 6.1 inches long. It has a triangular face with a height of 16 inches. The volume of the prism is 390.4 cubic inches. What is the base of its triangular face? Okay, so let's draw a little sketch here. I'll do it this way. It's 6.1 inches long. So let's put 6.1 over here. It has a triangular face with a height of, so it's pretty tall, a height of 16 inches. So we'll say that this dotted line is 16 inches. And then let's just finish off the prism. So this is a triangular prism. And let's go ahead and write our formula again. So we have the volume is equal to the area of the base times the height. Okay, so let's plug in the numbers that we know. We know that the volume is 390.4 cubic inches. So let's plug that in over here. All right. Now, this might be a little bit confusing because it says a triangular prism is 6.1 inches long. So that means that this part is 6.1 inches. I'm going to go ahead and plug that in for the height. So the height is really what is perpendicular to the base. So the base here is a triangle, which is sort of standing upright in the way that I drew it. But I could have just as easily drawn the triangular prism. I hope you can see this. I could have drawn the triangular prism like this, standing up like this, instead of on its side like this. So if I had drawn it this way, then you would clearly identify the 6.1 as the height of that prism. So just because I drew it like this, it doesn't mean that I can't say that the 6.1 is the height. Really, what we're doing is we are multiplying the area of the base by the length which is perpendicular to it, which would be this length over here, which we usually call the height. All right. Okay, so I'm going to put the 6.1 over there. And now, to find the area of the base, well, let's write that, first of all, I'm just going to put an X over here to mean the length from here to here. Now, the base here is a triangle. How would we normally calculate the area of a triangle? Again, let's go over to Frydman Math and just remind ourselves, it's actually right over here. To find the area of a triangle, it's the length times the height divided by 2. And when we say the height here, we don't mean the 6.1. Now, in this context, we mean the height of the triangle, which is 16 inches. So let's go ahead and put that into our formula here. So we will say that the area of the triangle is 16, which is the height, times the length, which is x, so I'll just write 16x, divided by 2. Okay? And when we solve this whole messy looking equation, then we're going to have figured out what the length of this triangle is. Okay? Or as IXL calls it, the base of the triangle. All right, so let's go ahead and solve that. Now, what we could do here is we could put this over 1, and then we're just multiplying two fractions together. So the denominators are just 2 times 1, so that would be 2. And the numerators are 16x times 6.1. So I'll go to a calculator and just do 16 times 6.1 equals 97.6. So in the numerator, I'm going to have 97.6x. And all of that over 2. And all of that is equal to 390.4. Okay, now there are a couple of ways that we could move on from here. We could multiply both sides by 2, and then we could divide both sides by 97.6. I'm going to just do it another way, which I think is a little bit simpler. I'm going to do 97.6 divided by 2 and get 48.8. So now I have 48.8 x is equal to 390.4. And now I just have to go ahead and divide both sides by 48.8. So that cancels, and I have x equals 8. Okay. Nice, easy number. So that means the base of the triangle is equal to 8 inches. Okay? Submit. All right. A triangular prism has a triangular face with a base of 11 feet and a height of 18.8 feet. Its volume is 620.4 cubic feet. What is the length of the triangular prism? Okay, so let's draw another triangular prism. This time the base is 11, the height is 18. We do not know what the length is, so I'll call that x. We do know what the volume is, that's 620.4. So let's go ahead and write our formula. Volume equals the area of the base times the height. And really, when I say height here, I mean this side from here to here. So let's plug in what we know. We know that the volume is 620.4. We know that the height, well, we don't know the height, but we're calling it x. And the area of the base, so that means the area of the triangular face over here. Well, to find the area of a triangle, it's the length times the height divided by 2. So let's write that in. We have the length of 11 times the height of 18 divided by 2. And this is getting multiplied by x. I'll use a dot over here because if I use the x for the multiplication symbol, then it looks confusing being next to this other x. So I'll just use the dot symbol to represent multiplication there. So this is not too hard, actually. It looks messy, but it's not too hard. So all we have to do here is 11 times 18, which is 198, and then divided by 2, which is 99. So we have 99 over here times x equals 620.4. Now we'll just divide both sides by 99. Oh, I'm sorry, I made a mistake. Yeah, I just realized I made a mistake. That should be not a big mistake, but this should be 18.8 feet. Whoops. 18.8 over there. So I should have had a 0.8 over here. So let me just back up a little bit. What I should have done is 11 times 18.8 divided by 2 is 103.4. So then we'll divide both sides by 103.4. And we get x equals... I, of course, am doing this all in my head. I'm just showing you guys how to use the calculator. You believe that, right? 3.46. Okay, good. So what does this 6 represent? That was the length, or if you want to call it the height, of the triangular prism. Okay? And that's that. Let's see over here. A triangular prism is 6 inches long and has a triangular face with a base of 6 inches and a height of 12 inches. What is the volume of the triangular prism? Okay, so the 6 long So that's what this one looks like. This question is asking us for the volume, which means we're not going to have to do inverse operations on both sides. And you'll see why in a minute. So we do not know what the volume is for this problem. That's what IXL is asking us for. What is the volume of the triangular prism? So we're going to leave this as a V. The area of the base, meaning the area of the triangle over here, would be 6 times 12, or 12 times 6 if you want, all over 2. And then we're going to multiply by the height, by which we mean this length over here, which is 6. So let's see. If we do 6 times 12 divided by 2, that's going to give us 36. So in my head, actually, what I did to answer that was just 6 divided by 2, which is 3, and 3 times 12 is 36. So that's another way you could have done it. You could have also done 12 divided by 2 is 6, and 6 times 6 is 36. So we have 36 times 6 over here equals V. So I said before we would not have to use any inverse operations on both sides. And the reason for that is because what we are looking for, the volume, is already isolated. There's nothing around this V over here that we're trying to get rid of. All of the numbers that we're working with are on the other side. So that means that all we have to do is evaluate this side of the equation. We do not have to try to cancel anything out by using inverse operations on both sides. So our last step is just to do 36 times 6, which would be 216. And that would be cubic inches, because this was inches, and this was inches. So we have inches times inches times inches, which gives us cubic inches. This 2 over here has no units. It's dimensionless. All right, so 216 cubic inches, submit. A triangular prism is 17 feet long and has a triangular face with a base of 18 feet and a height of 11 feet. What is the volume of the triangular prism? That question is exactly like the previous question that I just did. So I'm going to end it there. Reach out if you have any questions, and have a great day.